Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University, and you can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our actuarial students in the program, go to smarturl.it/help-ISU-actuary. Here's a problem for today. An insurance company insures red and green cars. An actuary compiles the following data. Color of car is red or green. A number insured, 300 for red, 700 for green. Note that this could be interpreted as the probability of a car randomly picked from an insured car being red as 0.3, and probability of a randomly picked car being green is 0.7, because all insured cars are either red or green. That's an important observation. Probability an accident occurs is 0.10 for red cars and 0.07 for green cars. Probability that the claim exceeds the deductible given an accident occurs from this group is 0.9 for red and 0.8 for green. The actuary randomly picks a claim that from all claims that exceed the deductible. So an important, again, what this means is that this actuary specifically goes to the claims that exceed the deductible and picks one of those randomly, but only from those. Calculate the probability that the claim is on a red car. Well, you can see that there's this flip-flop of probability going one way first and then a second way. So this is kind of like the Bayes theorem problem. You need to work with conditional probability. You should know that immediately. And what do? Well, the golden rule that I ask you to always follow is that in order to clarify things in your mind, you begin by labeling the events. So let R be the event that the car is red, and G be the event that the car is green. Let E be the event that a claim exceeds the deductible. And we are looking for the probability that the car is red given that, because remember, the actuary picked only from those that exceed the deductible. So that was given, that we exceed the deductible. So the probability we're looking for is probability of R given E, which by definition is probability of R intersection E divided by probability of E. And then we do have the probability of exceeding the deductible for red and for green, actually. So we can write the probability of R intersection E as probability of R times probability of E given R, and write the bottom as probability of E intersection R plus probability of E intersection RC. Well, the complement of R is actually G, so that's what the next formula says, because red cars and green cars all together form a partition of this probability space. And then we now basically write it as the formula you see in the Bayes theorem at the bottom. So it's probability of R times probability of E given R divided by probability of R times probability of E given R plus probability of G times probability of E given G. And remember, R and G form a partition of the space, so this is exactly like the Bayes theorem. So the top is 0.3 times 0.09, the bottom is 0.3 times 0.09 plus 0.7 times 0.04, and we plug it in and calculate, and it's about 0.4909091. And again, it's a conditional probability calculation because we are told that we are calculating the probability that the claim is on the red car, given that the actuary randomly picked the claim from all claims that exceed the deductible. Only those. So that was given already, that's why it's conditional probability. So it's answer C. Please remember this is copyrighted material. Problems from past actuarial examinations and study notes from Society of Actuaries are copyrighted by the Society of Actuaries and are used here with permission. Good luck in your studies and good luck on the test.